All right, hello everyone. So today we're finding the equation of a plane containing the line L of t equals 0.3, -1, 0, plus the vector 4, 1, -2 scaled by t. Okay, and the plane itself also contains the 0.733. All right. So the thing that we got to look at here is, first of all, how we find the equations of planes if there's a formula to go about this, and we do. And the idea here is each plane that we're looking at that we want has a normal vector to it. A normal vector is just a vector for which if you dot that normal vector with any vector on the plane, it's equal to 0. So what I drew here is the idea here. You have a vector that goes, you got a vector that goes from x, y, and z to x naught, y naught, z naught. And yeah, how would I write that vector between 2 points? You subtract the components from each other. So x minus x naught, y minus y naught, z minus z naught. Yeah, and that represents any vector that would be on the plane. And then that dotted with that normal vector has to be 0. That's always the case. The normal vector is perpendicular to the plane. Okay, so that's what we mean by that. So the most important thing is finding this normal vector. Now, how do I do that with this problem? So I'm given some information already that the line, first of all, is on this plane. And let me go ahead and draw that out here. Not like literally, but just to get an idea going here. So I'd have a line, and it goes something like this. And you've got a vector here that defines the line. It's 4, 1, -2, gives its direction. So let me just note that and call that u. So u equals 4, 1, -2. Okay. Now, a plane is defined by the span of two vectors, those vectors being non-parallel. So what I need to do is I need to find another vector here that's on the plane. Well, how can I do that? Well, I'm told that I've got the 0.733. What I can do is get another point on the plane and subtract the points from each other. Now, how do I get another point on the plane? You can certainly plug in a value for t in your equation, okay? So if you plug t equals 0, you would get the 0.3, -1, 0, and that's on the line and the plane. And I can form a vector, we'll call it v here. V is equal to 7 minus 3, 4, 3 minus -1, 4, and 3 minus 0, 3. Okay. So we've got two vectors, v, and the one that I got, u, which was a minute ago, was 4, 1, -2. That came from the vector in the line. So these two vectors, if you were to multiply them and span them, multiply by any real number on both, and then add them together, that's what we call the span. That span would produce this plane. Now, what's so important about that? Well, we said we need a vector that's perpendicular to that plane. Knowing two vectors now that determine the plane, we can go ahead and find the vector that's perpendicular to those two vectors using the cross product. Okay, so once you find that cross product between those two vectors that determine the plane, you can go ahead and reassure yourself that that's the normal vector for the plane. And yeah, how do I get a normal vector or to two vectors, or a vector that's perpendicular to both? You do the cross product. So let's go down here, and we have 4, 1, -2, 4, 4, 3. Then on the top here, I'm going to put I, J, and K. And the cross product is a lot like taking the determinant of a matrix. So for the I part, we're going to go ahead and cross this out, and then we're going to form the determinant of 1, negative 2, 4, 3, with the I next to it. The next one is going to be a minus, and then it corresponds to the j component. And that would be 4 minus 2, 4, 3, j. And then finally, the last component for k is crossing out the row and column that you have here for k. And then we're going to write the numbers that you have, 4, 1, 4, 4. That's k. Sorry, those numbers might be a little hard to see. Yeah, you might say your handwriting is not making it easier. I do apologize. I don't have the best handwriting here, obviously. And what we're going to do is we're going to take these 2 by 2 determinants. That way that works is you say 3 times 1, 3, minus 4 times negative 2, which is a negative 8. Put an I next to it. Minus, for the j component, it's 3 times 4, 12, minus 4 times negative 2, that's negative 8. And then plus 4 times 4, 16, minus 4 for the k. And if you did all this math, this would come out to be 11i minus 20j plus 12k. 11 minus 20, 12 is another way of writing this vector. And that would be your normal vector. Once you have your normal vector, you dot this with this vector we make that's on the plane. That's the one that I had earlier, which was x minus x naught, y minus y naught, z minus z naught. So yeah, we're looking at this equation right here. And what's x naught, y naught, and z naught? That's just a point that's on the plane. So 7, 3, 3 is a candidate for that. And this would look like this. Then all of that dotted equals 0. So you would get 11 times x minus 7. So we're doing a dot product now. 11 times x minus 7 minus 20 times y minus 3 plus 12 times z minus 3 equal to 0. Okay, and there you go. And that would be how you find your equation of a plane. So again, you need to find that normal vector. Each one of these problems involving finding the equation of a plane requires a bit of you looking into like what you need to do to finding that normal vector. It's not always as complicated as it could be easier, and sometimes it's a little more complicated. Okay, so just be on the lookout for that. All right, well, thank you for your time.